Good morning. This is gas laws tutorial number 2, and I'm going to introduce one more gas law today. That's the combined gas law, which you can see on the screen in front of you. And you can probably guess why it's called the combined gas law, because if you look at the top part, where you have the P1 times V1 equals P2 times V2, that looks like Boyle's law. But if you have the V1 over T1 and the V2 over T2, that looks like Charles' law. So when you put them together, we call them the combined gas law. And basically, it just means that as long as you know 2 of the 3 conditions, once a change has been made, you can solve for the third one. It's pretty straightforward. It's just adding one more variable in. Once again, remember the temperature always has to be in Kelvin. So if they give you Celsius, you'll have to convert that to Kelvin. And then the 2 pressure units we typically use are kPAs and atmospheres. So let's try one. Here's our first problem. A gas has a volume of 120 liters at STP. What is its new volume if the temperature increases to 100 degrees Celsius and its pressure decreases to 0.50 atmospheres? Well, this is going to take us back to something we discussed on the first tutorial, and that's the concept of STP. You may remember way back here on slide 3, we talked about STP, and that simply means standard temperature and pressure. So whenever you're told that a gas is at STP, you know its pressure and its temperature. And its temperature will be 273 Kelvin, because we have to use Kelvin. And then the pressure will either be 1 atmosphere or 101.325 kilopascals. How do you know which one to use? Well, you look at your problem to see what unit is being used. So in this problem, we are using atmospheres. So for our initial pressure, we're going to want to use 1 atmosphere. So remember that our actual formula is pressure 1 times volume 1 divided by temperature 1 will be equal to your new pressure, pressure 2, times your new volume, volume 2, divided by your new temperature, right? So that's our formula. What is my initial pressure, volume, and temperature? Well, they tell me that my volume is 120 liters, and I'm going to be really conscientious about keeping my units so I can keep track of what number means what. They've told me I'm at standard temperature and pressure, so that I know my initial temperature will be 273 Kelvin. And because I'm using atmospheres, I'm going to use standard pressure and atmospheres, which is 1 atmosphere. So that's what I'm going to have on the left. On the right will be my new conditions. So my new pressure, my P2, is going to be 0.50 atmospheres. My new volume is what I don't know. And for my new temperature, they tell me that's 100 degrees Celsius. Now remember, if they give me Celsius, I'm going to have to convert that to Kelvin by adding 273. So 100 plus 273 is 373. That'll go on bottom, like so. Now, this looks like a big hot mess to solve, but once again, I'm just going to do cross multiply and divide. So first, I'm going to multiply 1 atmosphere by 120 liters times 373 Kelvin. And then I'm going to set that equal to my other cross, which will be 0.5 atmospheres times V2 times 273. And of course, how will I isolate V2? I'll just divide both sides by 0.5 atmospheres and 273. That way V2 will be by itself. So when I put that in the calculator, what I'm going to get is a new volume of, well, initially I get 328 liters, but technically I only have 2 sig figs. So I'm going to round that to 330 liters. Once again, I'm always going to mention sig figs. Right now I won't be grading your answers based on if you have the right sig figs. I just want to know that you can do the problem solving. And so this is what that setup looks like. So hit pause and take a second and copy this example onto Pandemic Gas Laws number 2 so that you have it as an example. And then come back and we'll talk one last little bit. So you're back from outer space with that same old look upon your face. Sorry, getting a little stir crazy here. So hopefully you've gone ahead and worked those problems. I didn't tell you to do that. If you didn't do it, just hit pause again and go work those problems. But here are what the answers that you should have gotten if you set them up correctly. If you did not get these answers, these are the number 1 errors. 1, you didn't set up your cross multiply and divide correctly. Sometimes people do that. I found that when I'm setting them up, it's way easier for me to have a horizontal line to represent my dividing as opposed to the, where I do it all in one line. That kind of confuses me for the cross multiply and divide part. But try that part again. Another common error is people forgetting to convert the temperature to Kelvin. So go back and double check that you didn't put any Celsius temperatures directly in as Celsius. They have to be in as Kelvin. So you've done 4 combined gas law problems. And how we're going to wrap up this week is by having you do 6 additional problems, 2 each, of Charles Boyle's and combined gas, but you're going to have to figure out which gas law is appropriate based on reading the question. And really the main way to do that is just to focus on your units. If as you're reading the problem it only mentions pressures and volumes, well, what's the gas law that only uses pressure and volumes? Boyle's. If you're reading the problem and it mentions a volume and temperature, then you're going to use Charles because that's the gas law that only deals in volumes and temperatures. And then finally, if it has all 3, pressure, volume, and temperature, obviously that's going to be the one we did today, combined. So my recommendation is that you first figure out which gas law to use, and then you plug it in, set it up and plug it in. Remember, you have a week to do this, but you obviously don't want to take that full week unless you need it. I hope that you have a good weekend and that these short instructional videos have been helpful. Be sure to email me if you have questions, and please make sure you turn this in via Google Classroom. That makes it way easier for me to comment. And let me know if there's any way I can help you. I miss you guys. And that's all for today. So this was way shorter than yesterday, which is good, right? I hope that you have a good weekend, and I will talk to you later.